Welcome to Physics Unplugged, the podcast that makes revising physics topics feel like a chat with a friend. Today, we're diving into electricity, a topic that powers everything from your phone to your fridge. But how does it work? Stick with me for the next 5 minutes, and you'll have a solid understanding of the key ideas for your IGCSE physics exam. Let's start with a super important question. What is electricity? Well, at its core, electricity is all about charge, tiny, invisible particles, like electrons, moving through a conductor. This movement of charge is called current, measured in amperes, A. You can think of it like water flowing through a pipe. The more water, or charge, that flows per second, the higher the current. But what makes the charge move? That's where voltage, V, comes in. Voltage, or potential difference, is like a push that drives electrons through a circuit. The bigger the voltage, the bigger the push. It's measured in volts, V, and is found using V equals E, Q, meaning voltage is the energy transferred per unit charge. Now, imagine you're running through water. It slows you down, right? That's resistance, R, how much a component opposes the flow of current. Resistance is measured in Ohm's ohm symbol and follows the famous Ohm's law. V equals IR. Which means voltage equals current times resistance. Series versus parallel circuits. Picture a string of fairy lights. If one bulb goes out, the whole thing stops working. That's because fairy lights are often wired in series, where current is the same throughout the circuit, but voltage is shared. Now, think about your house. When you switch off your bedroom light, the kitchen light stays on. That's because household wiring is in parallel, where voltage is the same across all components, but current splits between branches. Here's a cool fact: the total resistance in a series circuit adds up, making it harder for current to flow. But in a parallel circuit, resistance decreases, meaning more current can flow. That's why your home is wired in parallel, to prevent voltage drops and keep appliances working properly. Why does this matter in real life? Let's talk about safety. The electricity in your home isn't a gentle trickle, it's 230 volts of AC, alternating current, at 50 Hz. Touching a live wire? Bad idea. That's why we use fuses and circuit breakers to stop dangerous currents from flowing. Earthing also helps by directing excess charge safely into the ground. And then there's power, measured in watts, W. Power tells us how quickly energy is transferred in a circuit. You can calculate it using P equals 4, meaning power equals current times voltage. That's why a 2000-watt kettle heats water faster than a 500-watt toaster. It's transferring energy at a much higher rate. Final thoughts and exam tips. Electricity is everywhere, and understanding how it works helps you grasp everything from why your phone charger gets warm to how streetlights stay on. If you remember just 4 things from today. 1. Voltage pushes the charges, and current is the rate of flow of charge. 2. Resistance is the restriction of current, not slowing down, just changing energy. 3. Series circuits share voltage, but parallel circuits share current. 4. Alternating current, mains, is currently flowing alternately in different directions.